So Mr. and Mrs. Wagner want a family picture taken with their children, Jeremy, Jesse, and Crystal. We abandoned Jamie. Too bad for him. In how many different ways can all 5 line up in a straight line for the picture if there are no restrictions? So that would just be 5 factorial, right? Because you'd have 5 lines, and you'd put 5 people here, then 4, then 3, then 2, then 1. Because you're sitting someone down each time, right? Now, we're doing the parents must be on both ends. Those are our restrictions, a parent and a parent. We agreed to say which parent on which end? No, so we have the option of either one. So we're going to go 1, 2, 3, 4, 5. Here we could have either parent, correct? Parent 1 or parent 2. So that would be 2. And then what do we have to do every single time we're arranging people? We have to leave one of them there, or we're not arranging people, right? We're just, hey, we could put 2 here, and then we don't put anyone there. And then, hey, we could put 2 here, and then we don't put anyone here. Eventually, you put no one nowhere, and you're still not taking a picture, right? So we have to leave someone behind. So we're in a box. I'm going to leave behind parent 2. And then we're going to have parent 1 here, which is one option, right? Then how many options do we have for this blank? 3. We have the 3 children, correct? And then we have 2 children because we leave them behind, and then we have 1. So it's 2 factorial, or 2. Why can I write 2 instead of 2 factorial? What is 2 factorial? 2 times 1. And what's 2 times 1? 2. And why can I write 2 factorial? Because I'll show you. Parent 1 and parent 2 make up 2 times 1, don't they? So I could write 2 factorial for them. Or I could just write 2, because 2 factorial is 2, right? That's why on a test you'll never see 2 factorial, because 2 factorial is 2. So they just write it as a 2. And then the green, so I could write the blue as 2. And then I could go times. And what's the green? 3 factorial. Why am I showing this? Because they could give the answer like that. Or you could literally go 2 times 3 times 2 times 1 times 1, which is 12. Okay? Baby Crystal must be in the middle. Does it say anything about the rest? Nope. So we go to where baby Crystal would be. She has to be here. How many baby crystals are there? There's 1. Then we can go to any blank after that, right? I always go to the far left. So how many kids do I have left for this one? 4. Then this one. 3. Then this one. 2. Then this one. 1. And I could represent that as actually 4 factorial, couldn't I? Because I have 4, 3, 2, 1, blast off. If I can rocket blast off, I can put a factorial where that blast off would be, right? So 4, 3, 2, 1. So I can go 4 factorial times 1. Do I have to multiply anything by 1? What does multiplying by 1 do? Gets you the same number. That's why you like the multiplication facts in grade 3 that were times 1. Because you were like, boom, I got this. Or 0. A game. Or 11. Multiplications of 11 were easy. They're just the number twice. So like 3 times 11, 33. 8 times 11, 88. That's why you like multiplying by 1. Because you just got the same number that you multiplied by, right? 1 is basically useless. 7 times 1, 7. 8 times 1, 8. You know? And 4 factorial is 24. The children alternate with the adults. If I want the children to alternate with the adults, what do I have to start with? If I start with the adults, I'm going to go adult, child, child. Have they alternated?
Child, adult, child.
Right. We have to start with the children because the children, there's more of them. Right? If I start with the adult, I'm going to go adult, child, and I'm going to have another child besides the child, and they're not alternating. So I always have to start with the bigger one first, right? So I'm going to go child, adult. So if I start with the children, how many children options do I have for this blank? 3. Then I sit one of them down or make them stay there at the very least. Then this is 2, then this is 1. And what does that blue represent? 3 times 2 times 1, blast off. 3 factorial. And then I go to the red, I have how many adults? 2, then I sit one down, then I have 1, and 2 times 1 can be 2 factorial, or I would just write 2. We're going to just enjoy that. Okay? No, that's why I said we're going to enjoy it. She brought that up, not me. We're going to keep that in our little back pocket. We're going to be fun. Okay, number 9. There are 3 boys and 3 girls on a mixed volleyball team. They want to take a picture of their team for the season where boys and girls alternate. How many different pictures can be taken? Try the question. How many of you picked boy first? How many of you picked girl first? That's way boring the second time. You start with a boy, girl, boy, girl, boy, girl. And you start with a girl, boy, girl, boy, girl. They're like, what is she doing? Okay, so it would look different if you started with a boy than if you started with a girl, wouldn't it? So most often, you guys are going to actually have only half the cases. You're going to either have the ones where they start with the boys or the ones where they start with the girls, because it's going to look different. The reason why this is different than the previous one is I had to start with children first, because I had an odd number of children and an even number of adults. I had more children than adults, okay? But on this one, I set you up. I gave you 3 of each. 2, 3, 4, 5, 6. So I could do boy, 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 girl, girl, girl. This would be 3, 2, 1. This would be 3, 2, 1. Which is 3 factorial, 3 factorial. We agree? That's one way. Or, because there's an even amount, I can make it look different by going 1, 2, 3, 4, 5, 6. Girl, girl, girl. Boy, boy, boy. Which is another 3 factorial, 3 factorial. And the or means you have to do what to them? Add. So what you need to remember is when you have an even number of both type, then you could have them one way, or you could start with the other type and have them another way. Okay? So that's times 2. So when you have an even amount of both, you have to remember to multiply by 2, because your one way could also flip-flop and go the other way. Does that make sense? So 3 factorial times 3 factorial is 36. 36 plus 36 is 72. So permutations and factorial notation. Curriculum outcomes. Solve problems that involve permutations. So a permutation is an arrangement of objects in a definite order. So order matters. So a permutation, order matters. Okay? So permutation is an arrangement of objects in a definite order. So order matters. So where each object appears only once in an arrangement. For example, ordering 3 stuffies. A kitty, a puppy, and a bunny. We're going to order them. Okay? I'm going to, and you're like, no, whatever. My daughter does it. My 6-year-old. She orders stuffed animals all the time. So how she could order it so it would look different is she could start with a kitty, a puppy, and a bunny. Could she not? Now she took a picture. What other arrangement could she do that if she took a picture it would look different? Yeah. That's exactly what I would have done next. Kitty, bunny, puppy. I would have kept the K and then just swapped the other 2. What else could we do? Yeah. Puppy, kitty, bunny. Keep going. You're on a roll. Puppy, bunny, kitty. He's allowed to, he's talking forward. He's talking forward. And then what?
And then bunny, puppy, and bunny, kitty, puppy.
And then that's as many as we can get, right? So that's 6 different permutations, 6 different arrangements in which it looks different. So if we have the word arrangement, that is one of the big giveaways. If they do use the word arrangement, that order matters. And if order matters, it's a permutation. So if I'm arranging anything in a specific order, if I'm taking a picture of something, then order matters. Then it's a permutation. Okay? So this expression, n factorial, can represent n times n minus 1 times n minus 2 times n minus 3. So we said 3 factorial is 3 times 2 times 1, which equals 6, right? And why would I do 3 times 2 times 1? Because I'm arranging 3 objects in a row for a picture, right? A kitty, a puppy, a kitten, a puppy, and a bunny. I should say kitty. I don't know. I said kitten, puppy, and bunny. Anyways, I would have 3 options for this first blank, and I'd leave one of the stuffies there, right? Then I'd have 2, and I'd leave them there, then 1. So it's 6, which is what I showed it was 6, right? So that's why it does work that way. In the expression n factorial, the variable n is defined only for values that belong to the set of natural numbers. So like 1, 2, and 3. So remember the factorial, you have to count down to 1 and then blast off, right? So you can't go to 0 and you can't use negatives because you stop at 1. So it'd be like, you can do 5 factorial, it's just 5, 4, 3, 2, 1, blast off. But you can't do negative 5 because we blasted off at 1. It's too low. You can't do zeros or negatives. That's for factorial. Okay? Next page. So, 6 factorial, we know what that is. It's just what? 6 times 5 times 4 times 3 times 2 times 1, blast off. So it's 720. Nine times 8 factorial is actually a weird way of just writing 9 factorial. Because you would go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Blast off, right? So this is actually the same as 9 factorial, which I don't know what that is. 362,880. Yes. 5 factorial over 3 factorial. We can actually reduce this and not even put it in our calculator if we want. Because 5 factorial is 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. So I can actually cancel off the 3 times 2 times 1 part. And it's 20. And I don't have to type it in my calculator. And then 3 factorial times 4 factorial, what's that? 6 times 24? 144. We're going to skip over example 2 for now. You're going to do the A and the B of your turn. Just the A and the B. I want you to try and do them without typing them in your calculator. So do them like I did this one here, the 5 and the 3. Should only take like 1 or 2 minutes. So here we have 10 factorial over 7 factorial. So we have 10 times 9 times 8 times 7. Do I have to keep going? Can I write 7 factorial? I can write 7 factorial. Why would I stop there? Because it matches anyways. And then 10 times 9 times 8 is 720. Yeah.
One question like this on like a test, if you just put 10 times 9 times 8, because you just saw that if you cancel it, if you lose marks for not showing like the canceling?
I would show the canceling because that's the important part. So we go 43 times 42 times 41 times 40 factorial over 40 factorial. What's 43 times 42 times 41? 74 what? 74,046 is what's 43 times 42 times 41. Yeah. Next page. So we're going to go to this formula. The number of permutations for a set of n different objects where r of them are used can be calculated using NPR, or the n factorial over n minus r factorial formula. The key to this formula is that n needs to be greater than r. So you can't go like 2p5. It can also be equal to. So you could go 5p2, you could go 5p5, but you can't make n be smaller than r. It can be equal to, and it has to be greater, but it can't be smaller, and your calculator will error you when you try to do it that way. All right. This formula can only be used if you don't have repetition. Okay? So remember above, when you're ordering the 3 stuffies, and you had 6 different arrangements, you had 3 stuffies and you ordered them into 3 spaces. The 3 stuffies, these stuffies are not being repeated, so you can use the formula 3p3. Now this is something I want to show you. So we had 3 times 2 times 1. We agree? That's what we had. I told you when you go 3 times 2 times 1, blast off, you can use 3 factorial, right? That's good. What you can also do is if you start at a number and you go down by 1, you can also use the p. Okay? I'm going down by 1 number each time, correct? So I can use the p if I go 3. That's always the first number I start with, whatever this number is. So 3, and then I can go p, and then I go, how many times do I count down by 1? 1, 2, 3, so then I put a 3 here. Okay? I'm going to show you how you punch into your calculator. So you're going to go You're going to go 3, and then you're going to go to that same spot you were yesterday for the factorial. Math, over to probability, and you're going to pick number 2. And we're doing 3p3. Now if you have an older calculator, it's totally fine. It's going to go 3 NPR 3. It's the same thing, okay? If it sets the NPR in between, this one just sets it in the right spots. And you still get 6. Now where the heck is the p good for? If I can just go 3 factorial. If I can go 3 factorial, why the heck would I go 3p3, right? It's more steps. I wouldn't. But if I have something like this, 6 times 5 times 4, and I stop there, right? So what does that mean? That means I have 6 objects and I'm placing them in 3 spots, right? So I can have 6 here, then 5 here, then 4 here. That's true, right? I have 6 objects and placing it in 3 spots. So in this case, it's like I have 6 stuffies and I can put them in 3 different places, right? Instead of 3 stuffies. Could I use the factorial symbol in this case? No, because I don't go 6 times 5 times 4 times 3 times 2 times 1 blast off. I have to say the blast off in order to use the factorial, right? So I need to be able to rocket count. I can't. But I can use the p because I said in order to use the p, you have to start at a number and go down by 1 each time, right? Which I did. So what number did I start at? I started at 6. P, how many did I go down? 3. I went down 3 spaces, correct? So I can go 6, P3. Instead of typing in 6 times 5 times 4. 6, math, 2, so 6P, 3. And then if I go 6 times 5 times 4, it's the exact same number. Okay? 6 times 5 times 4 isn't a really big deal. But if you go like 6 times 5 times 4 times 3, then it would save you more time. Also, they can go, your answer might be, I have 6 stuffies, you're placing them in 3 spots, and it can be done in the form A, P, B. Determine the values of A, B, respectively, right? So if they said that, and you could only do it this way, you wouldn't know what A, B, respectively are. So if they said, I have 6 stuffies, and I placed them in 3 ways, and it can be put in the form A, P, B, determine A, B, respectively, well, A would be 6, and B would be 3. What if you could only do blanks? Could you answer that question? No. Do you know the answer? Do you know how to do the question? Absolutely. So we have to be able to do it this way as well, just in case they ask for it in that form. All right? So we know we can use the P when we start at a number and go down by 1 each time. All right? Okay. Okay. So let's look at these. We're going to use the formula to show that it works with the formula actually too. This is your formula sheet over here. I thought this thing is over here. No, I don't. There's no one in that part. So this is actually the formula sheet you're going to get. I'm getting them laminated. But this is the exact formula on your formula sheet. There's an NPR formula right here and an NCR formula right here. So you don't have to memorize them. They're on the formula sheet. So the NPR formula is written above. I'm just going to rewrite it here. NPR equals n factorial over n minus r factorial. That's what your calculator is doing every single time you're going 6p3. It's going 6 factorial over 6 minus 3 factorial and doing the math for you. That's what your calculator is doing. Okay? So this is in the spot of n. This is in the spot of r. Is n greater than r? Yeah. An example for this would be, I want to arrange 8 stuffies. I have 8 stuffies and I want to arrange them into 3 different places. Right? That could be a question. That could be 8p3. So we're going to do it in the formula. So I'm going to put 8 in for the n's and I'm going to put 3 in for the r's. So it's going to equal 8 factorial over 8 minus 3, because it's n minus r, factorial. And 8 factorial minus 5 factorial. If you don't want to show the work, what would you put, Kyle? You didn't want to show the work, what would you just put? 8. Yeah. Because the 5 would just cancel off, right? But we can show that work. And what's 8 times 7 times 6? 836? I was like, that doesn't sound right. You do 6p5 in your formula. So for 6p5, we have to unfreeze the board. First step. But we have to n and r. So we have 6 factorial over 6 minus 5 factorial, which is 6 factorial over 1 factorial, which is 720. Okay? Isla has downloaded 10 new songs. See, it looks like Lila. My daughter's name, and it looks like Lila because the capital L looks like a, or capital I looks like a lowercase L, but it's Isla. I'm going to fix it if you would prefer to, so it actually says my daughter's name. Isla has downloaded 10 new songs from an online music source. So she has 10 to choose from, right? She wants to create a playlist. What happens with a playlist? She's 9. Don't cut down the 9-year-old, okay? Gosh. Well, she is. She's my daughter. She's not 75. Okay. So, when you put songs in a playlist, they play in a... They don't play in a shuffle. Does this say they shuffle?
Yeah. What are you doing?
That's what you're doing. But does this say that we're shuffling? No. When we put songs in a playlist, what happens to that playlist? They go in an order. So whenever it says playlist, it's a permutation because order matters. Yes, you can press shuffle and cause order to not matter. But even when you shuffle, they're still playing in a specific order. It's just a random order, right? Okay. So if she's going to put it in a playlist and the word arranged is here, we know it's a permutation. Because order matters. So she's arranging these in any order, which means like it doesn't have to start with the one specific song, right? They can start with whatever songs, but she's still arranging them in any order. How many different 6-song playlists can be created from her new downloaded songs? So we have 6, correct? So how many blanks can we make? 6. We can only do blanks because we are putting them in a specific order, right? If we were putting these in an order, we wouldn't be able to do the blanks. We can do the blanks because I'm going to put one song in number 1 spot, one song in the number 2 spot of the playlist, one song in the number 3, one song in the number 4, one song in the number 5, one song in the number 6. So how many options does she have for the number 1 spot of the playlist? 10, then 9, then 8, then because she can't repeat them, right? Okay? Now, we're going down by one number, we agree? Are we going all the way to 1? No. So we can't use factorial. But what could we use? The P. We could do 10. We have 10 songs. P. How many did we do? 6. These will get you the exact same answer. So type it in. 10P6. Yep. 10. Press 10. Then press math. Then arrow over to probability where you were before. And pick number 2. So 10P6. What do we get? Sam? You can just say the number.
151,200.
51,000?
151,000.
151,000, sorry. 200. So that's how many different playlists she can make with the 10 songs, picking 6 songs. There's a lot of playlists. Yeah. I'll shut you down. Works out well. Okay. Example 5. 9 girls are available to fill 3 positions on a hockey team: center, winger, and defense. If all girls are equally competent in each position, how many different ways can the positions be filled? So does the order in which I pick them matter? Yes, because I'm giving them positions. This is the key thing. Please listen. In order to know if it's a permutation or not, you have to look and see, did they get given specific jobs? If they were given specific jobs, it's a permutation because the order matters. So if I just had instead picked 3 of these girls to be on the team, then it would be a combination because the order wouldn't matter. They are either on the team or not. But the moment I picked these 3 girls to be on the team and I gave them specific jobs to do, so specific positions, it's a permutation. And I can do the blanks. Okay? So I can do 3 blanks. This would be center, this would be winger, this would be defense. Right? And I can do that because it's a permutation because I gave them jobs. Different positions. Or different jobs. Then it's a permutation. And then I can do blanks, yeah. Center, winger, and defense?
There's 2 wingers.
There's 3. But it says to fill.
Yeah, and there's 2 defense. Can you comment on that as well?
Yeah, I just cared about the wingers. I'm just filling 3 positions. The rest are all filled. Let's not overthink this. Okay. So, how many would I have for this? Also, there's not usually people who are equally competent for all the positions. It's kind of a crazy question, but let's not beat it out here. Okay, let's not kill the question. Okay, how many people here for center? 9. Then 8. Then what else could I have done? I have 9 players. P 3 because it's permutation, right? What's 9P3? 504. All right. And we're going to flip over. I want you guys to try example 6 and 7, please. Okay, so we have at a used car lot, 7 different car models are to be parked close to the street for easy viewing. So the different car models. So even if you have them in the exact same color of black, like they're the exact same color of black, and I lined them up, and I moved them around, you could tell that they moved, right? Even though they're the same color black, because they look different. However, if I lined up all of the same colored black cars, and you closed your eyes, and you covered your ears, and you couldn't hear anything, and I moved them, and I put them all back in the same spots, like same looking spots, but I actually moved the cars, you would say they didn't move, because they look exactly the same, right? But these are different models. If you have like the exact same color of like Ford Explorer, and then beside it you have like the exact same black, but it's like Ford Focus, little teeny tiny car, you can tell the difference. I don't care how perfectly black, same colors they are. Okay? You could tell the difference. All right. So it doesn't matter if it says different car models or same car models. Okay? So to use car lot, we have 7 different car models, and they're parked close to the street for easy viewing. The 3 red cars must be parked so that there is a red car at each end, and the 3rd red car is exactly in the middle. How many ways can the 7 cars be parked? Does it matter that I didn't tell you what the other colors are?
No.
No. I just know there's how many more? 4. And all I care about is where the red ones are parked. So I have to do that first. So 1, 2, 3, 4, 5, 6, 7. I need 1 on each end and 1 in the middle. So I need a red, and a red. So how many do I have for here? 3. Then what about the other ones? 4, 3, 2, 1. If you look at the reds, what could they represent? 3 factorial, and the blacks? 4 factorial. I think that's 144. We've done this one a ton of times. Okay. The 3 red cars must be parked side by side by side. Watch this. This is a trick. I lied. Wash your desks.